So everybody has this handout, and right here in blue, I already circled it because we've already learned this. All right, we've already graphed an equation with two variables. We know that there's an infinite amount of answers. We know that that's the reason why we graph, to represent the infinite amount of answers. And we know that when we graph a line, all the answers are on that line. So we're going to skip that. And we also already have done function form. I'm going to pause right here. I want you guys to try to do 1 through 6. Again, function form is simply getting y by itself on one side of the equal sign. So on number 1, where's the y at? The left side or the right side of the equal sign? Left side. Is it by itself?
Yes.
No, it's not. There's a +2 right there. So I need to get rid of that +2 by doing a -2. And of course, what I do to one side, I do to the other side. So what do I have left? The +2 and the -2 cancel out. And the 3x minus 2 I cannot do, so I just rewrite it. So y equals 3x minus 2. So it's all about getting y by itself. On number 2, I need to get rid of the minus 3x by doing the opposite, plus 3x to both sides. And since right here, yeah, the minus 3x and the positive 3x cancel out. But over here, since the 4 cannot be added to 3x, we're just going to rewrite it. So there's my answer, y equals. But instead of writing 4 plus 3x, I'm going to write 3x plus 4. Right? I'm going to write 3x plus 4. You always want the x term first and then the constant at the very end. Number 3, what do I need to do to get y by itself?
Divide by 2.
Divide everything by 2. When we divide everything by 2, the 2's cancel. I have y by itself equals 2 divided by 2 is 1, and you could have an x on it. You don't need the 1, but you could put the 1 if you want, and minus 3 at the very end. So there's your function form equation. All of these are function form now because I got y by itself. Number 4, I need to get y by itself. I do not want a negative y, so I'm just going to multiply everything by -1 or divide everything by -1. But at the end of it all, I'm simply going to change all the signs. That becomes positive, that becomes negative, that becomes positive. So my answer is positive y equals -x plus 5. Number 5, I want to get y by itself. Where's the y at? The left side or the right side? Right side. I need to get rid of that 5 by dividing everything by 5. When we divide everything by 5, 5 divided by 5 is 1. You have y by itself. That's what we wanted. 10 divided by 5 is 2 with the minus sign right in front. And the 4 divided by 5 you cannot do, so you're going to leave it like that. 4 divided by 5. But notice the x that was up here on top next to the 4, I'm going to put it on the side. And that would be nice for everybody to do. So we could call that a 4/5 x. I mean, you could technically leave it as 4x over 5, but it's better if you leave it as 4/5 x. Now, the only other thing that will make this function form equation look nicer is if you take the left side and the right side and just switch them. So let's make it y equals, instead of it equaling y, let's say y equals 4/5 x minus 2. There's a function form equation. The last one, I need to get it in function form. Wait a minute. It's already in function form, right? Y is already by itself. The only other thing you could do to make it look nicer is writing the x first and the +1 second. And that's function form. We need to know how to do that. Function form comes in handy when we're trying to graph, because if you write it in function form, it'll be like a machine, and you'll be able to plug in inputs and pull out outputs, which are really x and y values, which are really coordinates on a graph. So going up to the top right part of this page, steps to graphing two variable equations. Now, we've already done this in the past. Step 1 is to write it in function form, get y by itself. Step 2 is to make an xy table, and most of the time use 0, 1, and 2. And you plug in and you pull out and you get some coordinates and you graph those coordinates. So right here, right next to my graph, I want to do an input-output table. Why? Because y is already by itself, so it's already in function form. It's already ready to start doing inputs and outputs. So most of the time we use 3 easy numbers, 0, 1, and 2. We always use 0 because 0 always works beautifully. Anything times 0 is 0. So anyways, when I do plug in 0 right there, -2 times 0 is 0, and 0 plus 1 is 1. Thank you. And let's take the 1, the input 1, put it in. -2 times 1, what's -2 times 1? And what is -2 plus 1? -1, thank you very much. And the last one, take the 2, plug it in. What's -2 times 2? And what is -4 plus 1? -3. So as you saw, I didn't show any work, but I did do the input, got the output. Do the input, got the output. I put it in, I got out the answer. So these x and y values are actually coordinates. Let's go to the coordinate 0, 1. 0, 1 is right here. Let's go to the coordinate 1 on the x, negative 1 on the y. That's right here. Now let's go to the coordinate 2, negative 3. 2 on the x, negative 3 on the y. It's right there. Now you only need 2 dots to draw a line, 2 coordinates. But I do 3 just so I could really feel confident that I did it right, because all 3 dots line up. Just put some arrows on it and you're good. Now you only need 2, right? This other one, is it in function form? Yes. Go to an XY table. Always use 0, because 0 works out beautifully. Check it out. What is 1/3 times 0? Anything times 0? 0. And what's 0 minus 2? Negative 2. So when I plug in 0, I get out a negative 2, and that is a coordinate that I will graph. Now, I do not want to use 1. Why not? Because 1/3 times 1 is a fraction, and I don't want to end up with fractions, especially if we're graphing, right? So what number would be nice to plug in? A 3. So here's the deal, guys. Most of the time, we use 0, 1, and 2. But if you have a fraction in front of your x, when it's in function form, when y is by itself, if you have a fraction in front of your x, let's use that denominator, okay? So let's use the 3. If I had a 4, I would use a 4. If I had a 5 down here, I would use a 5. So whatever's in the denominator, when it's in function form, if you have a fraction in front of your variable x, use the denominator. So let's plug in the number 3. And let me show you that work. It's going to be 1/3 times x minus 2, and I wrote it right here. And I am going to plug in the 3 right in there. And when I plug in that 3, the 1/3 and the 3 completely cancel out. So what do I have left? I have 1 minus 2. What's 1 minus 2? Negative 1. So when I plug in 3, I get out a negative 1, and that is an answer. So let's graph the 2 answers. 0 is easy. We got 0, negative 2. And let's plug in 3 on the x, negative 1 on the y. There it is. And you know what? That's good enough. You only need 2 dots. Now let's say you wanted to make this line longer. You could plug in a 6, or you could plug in a negative 3. But to be honest with you, if you know you did this right, you could just use the pattern up 1 over 3 and keep going up 1 over 3. Yeah, you'll be off the graph, but that will be the correct next point. Or you could go backwards, over 3, down 1, or down 1 over 3, down 1 over 3, down 1 over 3, and get a dot right there. So either way, you only need 2 points. 3 is just to make us feel better. So I'm just going to use the 2 points that we got right there, then use the pattern to find more points. Now, some of these you're going to have to get it in function form. Like number 4, you'd have to first subtract 8, and then rewrite it, and then divide everything by 2. Then you'd have it in function form. Then you could use an XY table. Number 3, that one's really easy. That one is in function form. Y is already by itself. But what does it say? It says y equals x. Y has to equal x. X has to equal y. So if I did plug in a 0, that means that y would have to be 0. If I plugged in a 1, it would have to be, it would have to be 1, sorry. Plug in a 2, it would have to be 2, and so on and so on. So what kind of line do we get? We get 0, 0, 1, 1, 2, 2. It's just a diagonal line going right through the origin, right? Put an arrow there. If you wanted to, you could go with the pattern that way. But that's it. Easy peasy. Now let's jump to something interesting down here. You could memorize these 2 rules. That way you don't have to spend any time. It's not a rule, it's the truth. It says when you have x equals a number, it will be a vertical line crossing the x-axis at that value. So if you have x equals negative 3, x equals 5, x equals 1, x equals 0, x equals any number, and there's no y involved, then you could go to the x-axis and draw a vertical line right through that x value. Okay? So I could just go to my x-axis. Here's my x-axis. Go to the answer, negative 3, the value of x, negative 3, and just draw a vertical line right through it. Does that make sense? Now, if you're thinking, why? That's weird. Okay, let's really understand where this truth came from. Well, if you were to make an XY table, which I encourage, especially if you want to understand it, what does this say right here? It says x equals negative 3. So you don't want x to be 0, 1, or 2. It says x equals negative 3. X has to be negative 3. So you're going to put a negative 3, negative 3. And now what about the y? Are there any y's on this equation? No, so you don't have to worry about it. You could put 0, you could put -3, you could put +4, whatever you want for y, because there's not even any y's. And these are coordinates. So think about it. If I went to the coordinate -3, 0, that would be right here. If I went to the coordinate -3, -3, -3 on the x, -3 on the y, it'd be right there. If I went to the coordinate -3, +4, it would be up here. What kind of line is it? It's a vertical line going right through the x value of 3. So the shortcut is, if you have x equals -3, go to your x-axis, go to -3, and draw a vertical line through it. If it's x, it's vertical. If it's y, it's horizontal. Okay, so just for funsies here, what if I said graph x equals +4? What kind of line is that going to look like? Same thing, but where?
4.
On the 4. So it's going to be a vertical line crossing the x-axis at 4. Here's 4, and we said it's going to be a vertical line. See? Done. You don't have to spend any time on this. All you have to do is understand. If you have x equals a number, go to your x-axis, draw a vertical line right through that value. Now, if it says y equals a number, you're going to go to your y-axis and draw a horizontal line through that value. So y equals 2. Go to the y-axis, go to 2, and draw a horizontal line going right through that value of y equals 2. Again, you could make an XY table if you wanted to. You could say input, output. Now, the inputs, there's not even any x's involved. The only thing that this says is that y has to equal -2. So y has to be, not -2, +2, sorry. Y has to be 2, 2, 2. What about x? It doesn't matter what x is. You can put 0, you can put -2, you can put +3, whatever you want for x. And if you did graph the coordinate 0, -2, that would be that dot. If you graphed -2, 2, it would be right there. +3, 2, it would be right there. You'd still get that horizontal line crossing the y-axis at that value 2. So I hope we remember that. It's an easy way to graph without having to do any work. If it's x equals a number, it's vertical at that number. If it's y equals a number, it's horizontal at that value on y. Now, this is a very important part of the lesson. An equation is not linear if it has two variables being multiplied together. It would not be linear. Wait, first of all, what does linear mean? A straight line. So an equation, if you graph it, but it has two variables like x times y, then it's not going to be a straight line anymore. It's going to be something else. Or if a variable is in the denominator of a fraction. So if you have 5 divided by x, 2 divided by y, then it's not going to be a straight line anymore. If you have a variable that has an exponent on it, it's not going to be a straight line anymore. So we need to kind of memorize these three details so we could identify when we actually have a linear equation, an equation that produces a line, or a nonlinear equation, which is something else, maybe a curve or maybe pieces, but it's definitely not a straight line. So let's ask ourselves, number one, it's definitely in function form, y is by itself, but is it a linear equation or is it a nonlinear equation? It is. Oh, let's go through this. How about this? Does it have two variables being multiplied together? No, it's just x right there, y right there. How about the next one? A variable is in the denominator of a fraction. Is there even any fractions here? No. How about the third one? A variable has an exponent on it. No, the x does not have an exponent. The y does not have an exponent. 3 has an exponent, but that's not a variable. So is this linear? Yes, you can say linear. Everybody write that down. Number 2, linear or nonlinear? Nonlinear. Why? Because x and y are being multiplied together, and it says if you have two variables being multiplied together, it's not linear. So we're going to say nonlinear right here. It does not produce a straight line. How about this last one over here? Nonlinear. Why? Has an exponent on the variable, and it says if a variable has an exponent on it, it's nonlinear. Nonlinear. Okay? Just for funsies here, what if I put a number 4 and I put y equals 2 over x minus 3? That would also be nonlinear. Nonlinear. All right, we're good. Now, on the back side, we have some graphing, and you first have to make sure it's in function form, y by itself, and then you got to make an xy table, usually using the inputs 0, 1, and 2. However, if you have a fraction in front of your x, you have to use different denominators. Let's go over a couple of examples. Oh yeah, by the way, we did just finish function notation last week. Function notation is f of x, right? Or g of x or h of x. So don't freak out if you see f of x, because last week we said that f of x was the same thing as what? Same thing as y. There you go. That was kind of weird. Nobody said anything for a while. Okay, so f of x, this guy right here, is the same as saying y equals. So y equals is the same thing as saying f of x equals. G of x is the same thing as y. H of x is the same thing as y. Even over here, g of h, that's still the same thing as y. Because think about it, your h is your input, kind of like x, and your g of h is your output, kind of like y. So if you're confused with these function notation equations, please go back and rename them y equals x minus 2 and then just graph that. Okay? But it's the same exact thing, it's just using function notation. Now, if you do have it in function form, if the y is by itself, you just jump straight into your xy table and plug in some easy numbers for your inputs. Easy numbers like what?
0, 1, 2, 3.
0, 1, 2, 3, or any numbers you want, right? 0, 1, and 2. So when you do plug in 0 into the x, it's going to say 0 minus 2, which is negative 2. When you plug in 1 right there, 1 minus 2 is negative 1. And when you plug in 2 right in there, 2 take away 2 is 0. So you get your coordinates, you graph your coordinates, you put some arrows on it, you're good. That's how you graph lines. Now remember, you're not always going to use 0, 1, and 2. Like on number 5. Let's do a quick XY table together on this one. What inputs should I use? 0 is always great. The denominator 3 and definitely doubling at 6. Or 9 would also work. But the reason why I would hesitate using 6 on x is because you're already off the graph at 6, right? So if I wanted it to show over here on this side, what number would be nice to use? The negative 3 would be nice to use, right? Keep in mind, guys, what's important here is the denominator 3. Use that denominator. So 3 is great, negative 3 is great, 6 is great. But in reality, all you really need is 2 points. If you graph 0, check it out. Let's plug in 0 right in there. 0 times anything is 0, and 0 plus 1 is 1. If I plug in 3 right in there, let me actually show my work. Negative 2/3 times 3 plus 1. Yeah, the 3's cancel. That's why it's beautiful to use the denominator. And then what do we have left? You have a negative 2 plus 1. What's negative 2 plus 1? Negative 1. So just right there, just with those 2 points, you could actually finish and graph 0, 1 is right here. 3, negative 1, 3 on the x, negative 1 on the y is right here. And I already have my 2 points, so I could already draw my line. Whoops, that's an ugly line. But I could already draw my line. And if I wanted to extend it, I could use the pattern. I could say I go down 2 over 3. Or you could go backwards, over 3 up 2, over 1, 2, 3 up 2, and put a dot right there. So you could extend it as far as you'd like. Put some arrows on it and you're done. So for homework, I want you to finish this. And I will make a video explaining everything, hopefully by the end of this day.